Hi there. In this video, we'll be looking at the concept of specific specific resistance, or another word for this is resistivity. Resistivity. In the previous video, where we saw the factors that influence resistance, we saw that length and area of cross section, which are the geometrical characteristics of a conductor, characteristics. So these geometrical characteristics of a conductor can be used to talk about how the resistance is changing. We saw that if the length of the wire increases, the resistance increases. So we can conclude by saying that the resistance of a wire is directly proportional to the length of the wire, and the resistance is inversely proportional to the area of cross section, right? What does this mean? It means that if my length is doubled, the resistance would be doubled. Whereas if my area of cross section would have been doubled, the resistance would be half, right? So combining both of these relations, I can say that resistance is proportional to L by A. Removing this proportionality sign, I can introduce a proportionality constant and say R is equal to rho L by A. I can also replace this area of cross section with the formula for the area of cross section of a circle, considering the cross section is that of a circular wire. I could write this as R is equal to rho L by pi R square, right? Where R is the resistance, R over here is my resistance, L is the length of the conductor, and R is the radius of the cross section of the wire. So once again, looking at this formula that we just derived, R is equal to rho L by A, I can rearrange the terms such a way that I make the resistivity rho as my subject of formula. It would turn out to be R into A by L. Now, if I take a conductor that has an area of cross section as 1 unit and length as 1 unit, this would end up looking as rho is equal to R. So at this point of time, I can say that resistivity is nothing but the resistance of a conductor that has a unit length and unit area of cross section. That is resistivity of a material is nothing but is the resistance of a wire or conductor, doesn't matter, of a wire of that material of unit length and unit area of cross section. So this is the definition of resistivity. Resistivity is denoted by the Greek alphabet rho. How do we write that? It is denoted by the Greek alphabet rho. Pay attention. Start like this and go down like this. Sometimes in physics we also use this Greek alphabet rho to denote density. Okay, it is pronounced as rho, not R-O-W, R-H-O, rho. Now let us consider what happens when the length is doubled. Length is doubled. Now, considering that volume does not change, that is, the volume is conserved, if the length of a wire gets doubled, the area should get halved, right? It should become half. So, if I consider this, what would happen to the resistance? The original resistance would be rho L by A. Whereas, when I have doubled the length and made area half the original, this would turn out to become, say, let us call that R dash. Okay, let's call that R dash. R dash would become rho. The length has become double the original length, so it becomes twice of the original length, while the area has become half the original area, become A by 2. A by 2. So at this stage, rearranging these 2's over here, I can write this as rho into 2L by A into 2. This 2 in the denominator of A by 2 comes to the numerator. It would turn out to become 4 times rho L by A. But rho L by A was the original resistance. So I can write R dash, which is now my new resistance, is 4 times the original resistance. Correct? Now the same thing, let's consider what happens when, say, I make length thrice the original and the area as one third the original. One third of the original. If this would happen, what would happen to my rho L by A? It would turn out to be, let me just draw a line over here to bifurcate these two. Okay, so my new resistance R dash would be rho into length has become 3 times the original, so 3L by, because I made length thrice and I'm saying that my volume is being conserved, my area of cross section would become one third, so it would become A by 3. Rearranging these terms, I would get R dash is equal to rho into 3L by A into 3, which is nothing but 9 times rho L by A, correct? So I end up getting my new resistance R dash, my new resistance R dash is 9 times the original resistance. Alright, so this is about how the resistance would change if the length and area would change. Next, we look at the unit of resistivity. The unit of resistivity. We saw that R is equal to rho L by A. Isolating rho onto the left hand side, I get rho is equal to R into A by L. Correct? So now, if I want to find out the unit of resistivity, the unit of resistivity, I'm going to write rho here, is going to be the unit of resistance R into the unit of area of cross section A divided by the unit of length. So talking about this, the unit of resistance R was ohm, right? The unit of area, considering SI units, would be meter square, and the unit of length is meter, right? So this meter and the meter square would get cancelled out. I would get the unit of resistivity as ohm meter. Okay, you don't need to write it always like this. You could also write it as ohm, OHM. Remember, start with lowercase o, put a hyphen, meter. This is the unit of resistivity. The final thing that we have to talk about is the factors that influence resistivity. I'm going to use the Greek alphabet. Don't just get used to it. Okay. So the factors that influence resistivity are: one, the material of the conductor, the type of material, I would say, the type of material and the temperature of the conductor. Okay. Now, depending on the type of material, resistivity varies. For example, like we've always been talking about, we have different types of materials in nature. They could be conductors, insulators, we have semiconductors, there are superconductors, etc. So, conductors usually have a resistivity in the range of 10 to the power of minus 8 to 10 to the power of minus 7. 10 to the power of minus 8 ohm meter to 10 to the power of minus 7 ohm meter. Whereas those of alloys usually lie in the range of 10 to the power of minus 8. While if we look at semiconductors have resistivity in the range of 10 to the power of minus 5 ohm meter. These are not exact values minded, these are the ranges, that is, it lies around this range. Okay. Finally, insulators on the other hand, have resistivity of in the range of 10 to the power of 8, 10 to the power of 8 ohm meter to 10 to the power of 16 ohm meter. If you think about it, if you look at these ranges, conductors start off at 10 power minus 8. This is the least value of resistivity, while insulators have a very large resistivity of the order of 10 power 16. That is nearly 10 to the power of 24 orders of magnitude difference. You can say that resistance, you can say that materials that have a very low resistivity have a very low resistance. If the resistivity is low, it directly implies that the resistance is low. While if the resistivity is very large, it means that the resistance is going to be very large. Alright. So this is these are one of the factors that influence resistivity. That is the type of material. Coming to the temperature of the conductor, the influence of temperature on the resistivity is a little bit different for the type of material. Here we were talking about temperature of the conductor. So de depending on the temperature, the resistivity of the conductor would vary. If we increase the temperature of the conductor, the resistivity increases. While that for semiconductors is quite opposite. If we increase the temperature for a semiconductor, the resistivity would decrease. So one thing to note about the factors that influence the resistivity: geometrical features of a conductor such as the shape and size does not influence the resistivity. It is independent of the type of shape and size of the conductor. Why is this? Resistivity is the property of a material. If a wire is stretched to increase its length or it is doubled on itself, the resistance of the wire will change, but the resistivity will remain unchanged. Resistivity is only the characteristic of a material. So this is about the factors that influence resistivity.